Hi, my name's Elizabeth Tasker. I am originally from the UK, but now I am a researcher at JAXA and ELSI, and today I'm going to be talking about hot Jupiters and planetary migration. So exoplanets are planets that orbit any star that is not the Sun. And one of the first exoplanets we discovered was a planet known as 51 Pegasi b. And this was a planet with a similar mass to our own Jupiter, which is the largest planet in our solar system. But while Jupiter has an orbit of almost 12 years around the Sun, 51 Pegasi b orbited its star in just about 4 days. And as we discovered other exoplanets orbiting other stars, we found other examples of these huge gas giants that orbited in very short orbits. And these became known as the hot Jupiters. And the question was, how do these form? So, young stars are surrounded by disks of dust and gas that we call the protoplanetary disk. And inside these, microscopic grains of dust collide and stick and become steadily bigger and bigger until eventually you see something that looks like a planet. Now, close to the star, we don't expect much in the way of dust and gas because the star's evaporated it all. Therefore, we don't really expect giant planets to be on very short orbits like this. Instead, we expect them to form much further from the star, where it's cooler and there's plenty of building material. So what we suspect happened is that planets such as the hot Jupiters started forming far from the star, where there was lots of building material. Now, when they reached roughly the size of Mars, which is not a big planet, it's only about 1/10 of the mass of the Earth, they gathered enough gravity to start really pulling on that surrounding dust and gas, which pulled back. Now, gas and dust that is closer to the star than the planet is moving faster than the planet, whereas dust and gas that's further out is moving slower. And these two regions act as a drag force on the planet, with the planet being pulled forward by the gas closer to the star and being dragged back by the dust and gas that's further out. And if you sum up all these forces, what you typically find is there's a net force inwards towards the star. So what this means is that you can start forming a planet a long way away where there's a lot of building material. And as it steadily gets larger and larger, it feels this force inwards and it starts to spiral inwards towards the star. And this is called planetary migration. So you can form a big planet far out where there's lots of material. It can then migrate inwards and end up on a very short orbit around the star. And this is one way that we think hot Jupiters can form. Thank you.